All right, let's get right into it. We're about to pull back the curtain on the one simple principle that powers, well, pretty much everything in your life. It's an incredible story of motion, magnets, and a machine that literally changed the world.
No, really, think about it. The lights in your room, the phone in your hand, even the screen you're looking at right now, it all starts with a spin. And I don't mean that in some metaphorical way. I mean a literal, physical rotation.
Now you might be thinking, what about coal or natural gas? And yeah, the energy source might involve burning something, but that's not what actually creates the electricity.
And it's definitely not from something just glowing hot. The magic, you see, isn't in the heat or the light itself. It all comes back to this one simple action: spinning. That constant rotation is the master key that unlocks our entire electrical grid.
So, what is this amazing machine? It's called a generator. And here's a cool way to think about it. You know how an electric motor uses electricity to create motion? Well, a generator is its perfect opposite. It takes motion and turns it into electricity. Honestly, if you only remember one thing from this whole explainer, let it be this. This is the secret sauce right here. Just by moving a magnet, you can generate an electric current. It's so beautifully simple, it's almost hard to believe.
And it is no exaggeration to say this one idea completely rewired our civilization. I mean, before we figured this out, our world was lit by fire. After, it was lit by wire. That is a massive shift. The fancy scientific name for this whole effect is electromagnetic induction. But the idea behind it is so straightforward. When that invisible magnetic field from a magnet sweeps across a coil of wire, it literally gives the electrons in that wire a little push, forcing them to flow. And that flow, well, that is an electric current. You don't need a battery, no complex chemistry, all you need is motion. Okay, so the core principle is motion. We got that. But, a generator doesn't just spin all by itself. It needs a serious push from some kind of powerful force to get it going. So the next big question is, what's doing the spinning? And this is where all our different power sources finally enter the picture. Hydroelectric dams, they use the force of falling water. Coal and natural gas plants, they create super high-pressure steam. Wind turbines, obviously, catch the breeze. And hey, even nuclear power is really just a super sophisticated way to boil water to create steam to, you guessed it, spin a turbine. They're all different paths to the exact same destination, making something spin. So if you were to crack open a generator, you'd find two main parts working in perfect harmony. You've got the rotor, that's the bit with the magnets, and just like its name says, it rotates. And then you have the stator, the part that stays still, or stationary, and it's lined with huge coils of wire. The real magic happens right as that rotor spins, sweeping its powerful magnetic field right past the stator's wires over and over again. Now, this simple setup, a spinning magnet inside a coil of wire, it has some really fascinating, almost unexpected side effects. This isn't just a brute force machine. There's a real elegance to how it works that ended up shaping our entire electrical world. And here is one of the coolest parts. As one pole of that spinning magnet, say the North Pole, passes a wire, it pushes the current in one direction. But as it keeps spinning, the opposite pole, the South Pole, sweeps past and pulls the current back the other way. This constant push-pull, this back-and-forth reversal, is what we call alternating current, or AC. See, generators don't try to make AC power. It's just the beautiful natural result of their spinning design.
And the scale of these things is just staggering. On one end, you can have a tiny little generator and a hand-crank flashlight that literally fits in your palm. And on the other end of the spectrum, you have power plant generators that weigh hundreds of tons, machines so huge they have to be moved by massive cranes, and a single one can power an entire city.
But the biggest secret, the absolute best plot twist in this entire story, is that a generator is also a motor. And a motor is also a generator. They are the exact same machine, just running in reverse. If you put motion in, you get electricity out. But if you put electricity in, it will start to spin and create motion. They aren't two different things. They're just two sides of the very same electromagnetic coin. I just love that. It is a perfect example of pure engineering elegance. One device, two opposite jobs, all depending on which way the energy is flowing. It's not just clever, it's a fundamental principle that makes so much of our modern tech possible. Okay, so we've talked about the big ideas and the giant machines. But let's bring this all the way back home. How does a machine that weighs hundreds of tons actually connect to the device you're holding in your hand?
Let's make this really personal. Think about that simple, everyday thing you do, just plugging your phone into the wall to get a little juice. That one little act connects you, through miles and miles of wire, to a massive generator somewhere out there. Whether it's water falling down a dam, the wind turning a blade, or steam rushing through a pipe, that spinning is happening right now for you. It's a direct, physical link between incredible industrial power and your own personal device. So the next time you flip a light switch, just take a second to remember that incredible journey. The raw physical power of motion, a river flowing, the wind blowing, was captured, transformed by a spinning magnet, and sent across the country. All of that just to deliver a little bit of light to your corner of the world. It's a quiet miracle we get to live with every single day.